Let's now look at what happened at the positive electrode known as the word anode. What happened there? How do electrons leave the anode, and how does electron enters the anode? So looking at that from the battery, from the half cell diagram I've drawn, the battery is there, and you have the anode. The first thing you must know that negative ions, known as anions, always get attracted to the anode because they are opposite charge, and this electron enters the external circuit at the anode, right? Now what really happened? The anions that are attracted to the anode give up their extra. That's what they do. They give up their extra electrons to the electrode, that's the anode, forming atoms or molecules. These negatively charged ions give up, known as anions, give up their extra electron. Not just all their electron, the extra electron, the electron they gained before, to become their respective form again as neutral molecule. So give up their extra electron to the anode, invariably forming atoms to molecules. Call that process oxidation. Oxidation always takes place at the anode, while reduction takes place at the cathode. Don't forget. So let's look at how actually this happens. So let's look at this from the cell diagram. Right? As you can see, the electron enters the external circuit at the anode. Now, let's look at the various words. If you look at the anions, I've written there. The anions, you have the sulfate ion, you have the hydroxide ion, you have the oxide ion, and you have the chloride ion. There are others in the group 7. That's the halides. This is chloride, bromide, iodide, bromide. They have the same pattern of discharge. So let's look at how all of these, right? All of these are the anions, the negatively charged ions. They all go to the anode. Anode. Let's assume I will discharge. If this one gets to the anode, now which one of them will discharge, not all. Let's assume I'm discharging chloride ion. Chloride ion. If you look at chloride ion discharge, it can be written as this. Chloride ion. Let's look at the discharge of chloride ion in detail. If chloride ion from the electrolytes, let's assume, let's say is molten sodium chloride, and you have this one before it was having, this is chlorine, this extra, it's of only 287. It gained an electron before from a cation and becomes 288. So it has one electron extra, because the proton here, if you look at the proton here, is plus 17. The electron is minus 17. So the net charge here is 0. Now if you look at the proton here, it still remains 17. The electron is now 18. So this is the extra, and the net charge here is minus 1. Now you see the minus on top there. So it has an extra electron. That extra electron needs to be given up to the anode during for it to be discharged. It's an atom. To change this one back, they need to give what it took earlier on back to where this is from, right? From a cation. Now to do that, it needs to, this is the minus. Minus in front of the electron means electron lost, or electron lost, or electron given up. This electron goes to the anode, right? And this is the chlorine. It's the chlorine atom. So the chlorine atom will now aggregate, will now combine to form what? Molecule. That is, if you have this, and you have this, sorry, and you have this. So this is the extra. To have a molecule, this is the gas that has come out. So you have to put 2 in front, then 2 here, right? So this is chloride ion. This is what? Chlorine what? Gas or molecule. This is a neutral what? Substance and neutral what? Element. This is what? Having extra. This is not having extra. This is just normal. This is what? Chlorine molecule. So this is how the electron minus. So that electron, that is, if chlorine comes here now, which is a negative ion, you have this, you have this. So this one gives, this one gives, and these two will now combine and they form this. Right, you see bubbles, a greenish yellow vapor around here, a light green yellow vapor around here. That's what you observe, and that is what the chlorine gas, and that electron given up there moves upwards, right? The electron moves upward, be pulled by the battery and gets to the what? Cathode. So electrons enters the anode electron enters the anode, and these electrons are actually, if you look at it, the electrons given up by the what? The anions, and the battery will now do the pushing. It does the pushing and pushes the electron around what? The this extra electron around the external what? Circuit via the copper wires. Don't forget. So this is what happened, right? At the what? Anode. At the what? Anode. I'm just giving a case study, so don't forget. So as you can see from the diagram, this is a part of the electrolytic cell. That is talking about the internal circuit, where you have the ions. Ions move. The charges that move inside the electrolyte are ions, and these ions could be what? The anions or cations. So with reference to the anode, you can see that the anions, which are negatively charged ions, they are attracted to the anode, which is positive, and when they get there, they give up their extra electron to the anode, and they become discharged. There's no charge, they become neutral, and they become what? Their respective atoms or molecules. So this is how electrons enters the external circuit at the anode. Very, very important. Very, very important. So for this so this is like what I've written here now is called the anode. Is the anode half cell equivalent. Is half. I've only drawn one of the electrode. The complete one is the one you have the anode drawn and the cathode drawn. That redox reaction, redox. Because here you have oxidation. What we did earlier on about the cathode is what? Another what? Half cell equation. So combined we call the complete or next cell equation. So this one is oxidation. Oxidation takes place. Oxidation takes place at the what? Anode. Don't forget. The anions, the charged particles that go, the charged ions that go to the anode are anions. Anions A, they go to the anode, while cations go to the cathode. C for C, A for A. Don't forget that. Anions to the anode, while cations to the what? Cathode. Don't forget that. A for A, C for C. Don't forget, right? So this is the discharge, right? That's oxidation. Oxidation invariably means in terms of electron transfer, oxidation is electron what? Loss. Electron loss. When you lose the electron, you're not going to what? Oxidation or increased oxidation number. So your number here is what? -1 for chloride ion, and here is 0. So from -1 to 0 is an increase. You can define oxidation in terms of in so many ways, but reference to this, because oxidation is electron lost. electron lost or an increase in oxidation number, right? Chain number. That's oxidation. So oxidation takes place always at the anode. Reduction is always at the what? Cathode. So this is what happened. This is what happened at the anode. This is what happened at the anode. Don't forget. So this is what happened at the anode. Don't forget. I've explained them that the anions gets to the what? Anode, and the cations get to the what? Cathode. And if you look at the anode, oxidation always takes place at the anode, while reduction takes place at the what? Cathode. So two of them, they are both half-half. So if you combine them, it becomes the complete half-cell equation, which is known as what? Redox. And redox reaction takes place at the electrodes. Redox, oxidation and reduction taking place simultaneously. As one ion is being reduced, the other is being what? Oxidized, right? Taking place at the same time or simultaneously. That's called redox reaction. Oxidation, reduction taking place at the same time simultaneously at the electrodes. So redox reaction takes place at the redox electrode. And this one brings about what we know as a chemical change. Don't forget, the electric current causes a chemical reaction that breaks up the ionic compound. Very important. The electric current causes a chemical reaction that breaks up the ionic compound. Once it's broken up, you see, chloride ion is now free. It's broken up freely. It's now neutral. It's no longer attracted to any other ion. So that is what we call electrolysis. Electrolysis, right? Using electric current or DC power supply to break up electrolyte in the aqueous form or in molten form to their respective elements. Don't forget. Hope this is understood. Thank you.